Dear students, Assalamu alaikum. I hope you have gone through the first lecture of trigonometry, in which we discussed ratios of trigonometry and how to remember those trigonometric ratios and some basic properties. Now, in this second lecture of trigonometry, once we will analyze further properties of these ratios. So in this lecture we are going to study some more properties of trigonometric ratios before going to solve some examples. जैसा कि थोड़ा सा रिवाइज में करना चाहूँगा, मैंने आपको कहा कि अगर कोई राइट ट्रायंगल है ABC is a right triangle, right? Suppose this is the angle, then this is perpendicular, then this one is opposite side to the angle which you are going to take is perpendicular. This is base, then this is obviously 90, right? Opposite side of 90-degree angle is hypotenuse. Then I have already told you there are 6 possible ratios, and you can remember those ratios with Pandit Hari Bhatt, where P by H is the sin theta, B by H is the cos theta, B by H is the cos theta, P by B is the tan theta, and then there are 3 more ratios: hypotenuse by perpendicular, inverse of this cosec theta, base hypotenuse by base, inverse of this sec theta, base by perpendicular, tan theta, cot theta, perpendicular by base, tan theta, base by perpendicular, cot theta. Up to this इतना तो हमने कर लिया, ये तो हमने कल के लेक्चर में कर लिया. अब एक और बात, अगर कभी कभार किसी भी ट्रायंगल में एंगल सेम होगा, जब तक एंगल सेम होगा ट्रिग्नोमेट्रिक रेशियो चेंज नहीं होगी. दैट मीन्स इफ द एंगल इज सेम, इफ द एंगल इज, दिस द प्रॉपर्टी, इफ द एंगल इज सेम trigonometric ratio, T ratios, trigonometric ratios does not change. I will explain this property, what is meant by this property, कि अगर एंगल, जब तक एंगल सेम होगा ट्रिग्नोमेट्रिक रेशियोज चेंज नहीं होते हैं. दैट मीन्स जो ट्रिग्नोमेट्रिक रेशियो होते हैं वो एंगल पे ज़्यादा मैटर करते हैं, साइड्स पे मैटर नहीं करते. अगर किसी ट्रायंगल की साइड्स, अगर सपोज 2 ट्रायंगल्स है, उनमें से साइड्स डिफरेंट हो गए, अगर एंगल सेम होगा तब उस वक्त रेशो उस वक्त सेम आएंगे. यानी कि साइड के बढ़ने या कम होने से रेशो में कोई फर्क नहीं पड़ती है, सो फार एज द 2 एंगल्स आर सेम इन दोज 2 ट्रायंगल्स. लेट अस एक्सप्लेन दिस प्रॉपर्टी. For instance, we have a right triangle. Suppose we have an angle A. This angle is, say this is 30 degree. Suppose theta is here equal to 30 degree. Now if I join a perpendicular from this point, suppose this is angle A and BC is the perpendicular, then ABC is a right triangle. If I draw one more perpendicular, say this is P and Q, if you look at the triangles, this is also AQP is a right triangle. ABC is also a right triangle. In both the cases, angle A is common to both, so both have angle 30 degree. Now, if I find all ratios with respect to this angle, I will find sine A, sine theta, sine 30 degree, sine A, sine B, sine C, इसी तरह in both triangle ABC and ABQ. Though the sides are different, suppose base is AB, here base is AQ. So in triangle ABQ, bases are different, not equal. In the same way, perpendicular BC, here PQ, so obviously PQ is greater than BC. In the same way, hypotenuse of ABC is triangle is AC, and in this triangle hypotenuse is AP. So though the angle is same, but the sides are not same. But my point is that even though the sides are different, as the angle in both the cases are same, if you want to find trigonometric ratios on this angle, which is same, angle A, then trigonometric ratio in both the triangles will be same. It doesn't make any difference when the sides are different, so far as angle is same. So let us prove this point. In this triangle, as triangle ABC and triangle AQP are similar triangles. The reason is AA corollary. Because angle A is 30 in both cases. In angle AB, triangle ABC, angle A is 30. In angle PAQ, angle A is 30 degrees, so angle A is same. Angle B is here 90, angle Q is so these triangles are similar. Now these triangles are similar, that means their corresponding ratios are, corresponding sides are proportional. So AC divided by hypotenuse of this AC and hypotenuse of this triangle AP equal to base of this AB divided by base of APQ triangle, that is AQ, equal to perpendicular of this side BC divided by perpendicular of this side PQ. So all these sides are proportional. That means the ratio of AC by AP equal to AQ by AB by AQ equal to BC by PQ. As all the three equal, let us suppose they are equal to K. Suppose, say these are equal to K. Let us say it is equal to K. Because their ratio is same, I will take it equal to K. Then AC by AP equal to K implies AC equal to APK. K times AP. In the same way, AB equal to K times AQ. And BC equal to K times PQ. Now I will find sine theta in both the triangles. Sine A or sine theta. Here A is theta or sine 30. Sine A equal to, here angle is A, sine A equal to perpendicular by hypotenuse. Here perpendicular is BC, because theta is up, theta is angle A is the theta, so up angle opposite angle, side opposite angle is BC, so BC perpendicular BC by hypotenuse AC. And if I find angle sine A in this triangle, AP AQP sine equal to base PQ divided by PQ divided by AC AP PQ divided by AP. Now suppose I will name it first and here I will write sine. BC equal to, if you look here, BC equal to Q times K times PQ. So I will write K times PQ divided by AC equal to K times AP. K and K will get cancelled. I got PQ by AP. This is second. From first and second, sine A equal to from first equation sine A equal to AP by AQ. From second, sine A equal to PQ by AP. So in both triangles, sine A equal to AP, PQ by AP. In the same way, we can find cos theta and sin theta in both the triangles equal. Cos A by sin A in both triangles equal. Tan A by tan A in both the triangles equal. And similarly for other remaining ratios. That means when angle is same in two triangles, if the angle is same, then their ratios are same. That means ratios doesn't depend on the lengths of sides. It depends on angle. If the angles in two triangles are equal, then their ratios, trigonometric ratios, are also equal, no matter what their sides are. So this was one point which I proved here. That means ratios depend on angles, not on sides. One more basic point regarding this trigonometry is that when we write in exponent form trigonometric ratio, suppose I will write sine square whole square theta. It never means sine square theta and sine square theta and theta square. In case of simple algebra, when we were writing x square, we were writing it is equal to x square y square. But here don't write this is sine theta. Square will also be given to this. यहाँ sin को भी देंगे square और theta को भी देंगे square. This is wrong. This one is wrong. That means when we write sin theta is without theta, it doesn't have any meaning. So when theta is attached to this, then it is a ratio. Then it is a trigonometric ratio. Otherwise, it is not a trigonometric ratio. So here I can't write it's equal to, simply I have to write sine square theta. That automatically means ratio of the square of this ratio sine theta. Sine theta is a ratio square of that ratio. So don't give square to separately first to sine and then to theta. This is not correct. So sine theta whole square means simply sine square theta. That automatically means sine square of this ratio sine theta. Sine theta equal to p by h. That means square of this p by h. So don't confuse with this sine theta, that you simple algebra you will use that sine square of sine and square of theta as well. That is not correct. Now one more point regarding this. If sine theta raised to power minus 1, sine theta raised to power 1 is not equal to, if you use this logic, you will say then sine theta raised to power minus 1 equal to sine theta sine raised to power minus 1. This is known as inverse trigonometric functions. You will learn that in higher classes. Inverse, when you write minus 1 power over this, That means it is a symbol for inverse trigonometric functions, inverse trigonometric ratios, inverse trigonometric functions, You will study that in higher classes. Here sin theta raised to minus 1 is not equal to sin inverse theta. So these are two different things. This is inverse trigonometric function of sine. This is sin theta raised to minus 1. So these two are not equal. This is the symbol for inverse trigonometric function, which you will study in higher class. So never write these two equal. Last point regarding this. Now if you have suppose you have a triangle, I will take the question from exercise 8.1 so that you will get. The question is, you have a triangle ABC right angled at B. You have a triangle ABC. You have a triangle ABC right angled at B. Then it is your choice. You will write A here or C here, or C here, A here. But B is right 90 degree angle. B is 90 degree angle. In which AB equal to 24, BC equal to 7. AB equal to 24 centimeter, BC equal to 7 centimeter. You have to find first part sin A cos A, and you have to find sin A cos A. First of all, solution, as a part of solution I will write here sin, here AB equal to 24, AB equal to 24 centimeter, and BC equal to 7 centimeter. Using Pythagoras theorem, we can find the third. Using Pythagoras theorem, we have hypotenuse square AC square equal to base square AB square 24 square plus perpendicular square 7 square. 24 square equal to 576 plus 49. So 625. So this one will be 25. AC equal to under root 625. Under root 625 is square root of 5. So AC will be 25. Then our question is find sin A and cos A. Sin A, therefore sin A equal to perpendicular by base, perpendicular by hypotenuse. Perpendicular is here, it is sin A, so angle is A. Then opposite, this is perpendicular, this side is perpendicular, and this is base. Obviously this is hypotenuse. Perpendicular 7 by hypotenuse is 25. So you will get 7 by 25. In the same way, cos A equal to base by hypotenuse 24 by hypotenuse 25. So you will get 24 by 25. So this was how you can find sin A cos A. When you are going through this video, you should open your textbook and rough so that you can write down it and note down the pointers. Then second part is find sin C and cos C. Sin C equal to, but if I take angle as C, when the angle is C, base, and when now my angle is C, here angle is theta, is this angle C, then opposite side is perpendicular. So now this time it is perpendicular. Earlier it was base, now it is perpendicular because angle is now C, and this one is base. So sin C equal to perpendicular by hypotenuse. Here perpendicular is now 24. You will get 24 by base 25. Hypotenuse 25, and cos C equal to base by hypotenuse. Base is 7, hypotenuse is 25. So in this way I have done the question number 1. That means if two sides are given, you can find the third side with the help of Pythagoras theorem. Then you can find any ratios on acute angles, whether you want to find sine A, sine cos B, or tan A, or sine C, tan C, cot C. Up to you which ratio you are going to find. One more type of question is if one ratio is given and you have to, and the question is find the other two, find the other 5 ratios. So suppose it is given that sine A equal to 3/4. This is the second question of your textbook exercise 8.1. So let us suppose sine A equal to 3/4 is given. So first of all, you will make a right triangle. This is right triangle. This is A, B, C. So it is an acute angle here. Whenever sine A or sine C or sine P is given, whatever then take that angle is as acute angle. Don't take it as right angle. So that means either A is here or A is here, but A can't be here. So it is either you can write it here B or C, but you can't write it because it has given sine A equal to, so here it is always acute angle. So you can take it here either at this position or this position, but not at 90 degrees position. Now we know that sine A is the ratio equal to perpendicular by hypotenuse, implies then perpendicular by hypotenuse equal to sine A equal to 3/4, perpendicular by hypotenuse equal to 3/4. But we know that it's a ratio, some common factor is already cancelled, so I will take it as K. If you remember, अगर आपको याद होगा, अगर हम कभी कहते थे, सपोज हम कहते हैं कि दो साइड्स का रेशो 1:2 है, 1:2 है, फिर हम लेते थे रेशो में, हम लेते देन सपोज 3:2, फिर हम एक लेते थे 3x, दूसरा लेते थे 2x, क्योंकि एक कॉमन फैक्टर कैंसिल हो जाता है, वही हम एज x रखते थे. यहाँ पे भी ये ट्रिगोनोमेट्री रेशो है, सो p रेशो h is 3/4. So I will write p equal to 3k, where k is some constant or x, and hypotenuse equal to 4k. So this hypotenuse is 4k and this perpendicular is, then if angle is A, this is perpendicular is 3k. Now using Pythagoras theorem, we can find first AB and then we can find any ratios. Now using Pythagoras theorem, we have hypotenuse square, that means 4k whole square, equal to base square, base is AB square, plus perpendicular square, BC square, that means 3k ka whole square. So 4 square 16k square, 3 square 9k square, that means it will be here transferred to left side, that will be minus 9k square equal to AB square. 9 minus 6, 9 minus 6 equal to 16 minus 9, 7. So 7k square equal to AB. So it will be under root 7k square equal to AB. That means is under root 7 is not a perfect square, under root 7k equal to AB. So then this is under root 7k. Okay, under root 7k. This is under root 7k. Now let us we have now found that the base AB is under root 7k. Now we have to find the other ratios. Tan A cos A. So therefore cos A equal to base by hypotenuse, base under root 7k divided by hypotenuse under root 4k. So that is equal to under root 7 divided by k, and k will get cancelled, divided by 4. And per cos tan A perpendicular by base, perpendicular is 3k, angle here angle is A, opposite side is perpendicular, divided by base under root 7k. K and k get us cancelled, so you will get 3 divided by under root 7. So in this way you can find other ratios as well. So this was how you can find other trigonometric ratios if one ratio is given. In that case you have to use Pythagoras theorem and find first the third side, then after that you can find all the ratios using those basic formula for trigonometric ratios. I hope you have understood this lecture, and if you have any question regarding this you can comment that. Thank you. Have a nice day.